What's up, y'all? It's Afuego. Today's gonna be one of the good ones. We're gonna learn about Pandas, a library that's gonna save you a ton of headache when processing data sets. This is the 4th video in an 8-part series on Python libraries for data science and machine learning. If you haven't seen my first 3 videos on NumPy, SciPy, and plotting with Matplotlib and Plotly, definitely check those out. But today we're gonna be talking about Pandas, a library that's also compatible with NumPy, but makes dataset processing and manipulation much easier. Seems like everything in this series makes something easier. In the past, I did a lot of my dataset processing and manipulation by reading in CSV files from disk using the Python CSV module and processing that data using NumPy arrays. And don't get me wrong, this is still a great way to do it. Most of my research projects use that method, and I have no intention of rewriting that code. However, there are some things that are not that easy to do with NumPy. So in this video, we're going to give an overview of data processing and manipulation with Pandas. We'll first go over Pandas data structures as well as loading and saving capabilities. Then we'll discuss dataset manipulation, including subset selection, column manipulation, and creating and aggregating new columns. Finally, we'll talk about simple data visualization using Pandas, which is actually built into the library using Matplotlib. If you want the code for this video, it'll be at this link, which is also in the description as usual. Let's get into it. First thing we're going to do, like always, is import our libraries. We're going to import NumPy as usual for data generation, and we'll also import the entire Pandas library. Then I'm going to set the option to display all the rows and columns of every data frame that I print, just for the sake of us seeing the examples. The 2 main objects we like to think about in Pandas are the series and the data frame. The series object is an array-like object that often represents a single row or column within a data frame. They can be created and manipulated alone or used in conjunction with the data frame. It can also be manipulated in similar ways to the NumPy array, as seen in these 2 examples. We're creating a Pandas series using a list of integers as well as a NumPy random generator. Now both of these create a series, which is really similar to a one-dimensional NumPy array, but every row is assigned a unique ID. This unique ID is considered the index of the series. We can create a data frame from a series by passing in a single series, a list of series, or a dictionary of series as the data argument to the Pandas data frame constructor. Using a dictionary is nice because then we can set the column titles for every column in the dataset, as seen in this example. The Pandas data frame acts much like a matrix, except the rows and columns have unique IDs. Now let's get into indexing. We can select columns by directly indexing a data frame, as seen here. We use the integer or string ID of the column as the argument when indexing. If we want to index multiple columns, we can index using a list, just like we do in NumPy. We also want to note that operation performed on the resulting objects won't actually affect the original data frame. When selecting rows in Pandas data frames, we have to actually access the loc attribute within the data frame and index that. That allows us to index on the row level. This example created a data frame using Python code, but we can also load in data frames from files on disk. The Pandas library has many functions available for loading data, and the ones that we care about the most are the read table and read CSV functions, which allow us to read plain text files that are separated by white space or commas and new lines. There are also built-in data frame writing functions, such as the dataframe.toCSV function, which is also useful, but not necessarily contained within the main library. So I definitely check the documentation if you're curious. Now we're going to load a data frame, and this is going to be data from NBA injuries from 2010 to 2018. I stored this as a CSV file in my drive, and I'm going to use the gdown command line function to actually save this to my local environment. When I put an exclamation point at the beginning of anything in one of these notebooks, this is actually executing command line rather than Python code. Now we can load the CSV file, and we see that each row in the data contains a unique date, team, player, and notes on the injury. Now let's get into some manipulation. He don't know no cash now. Let's do some simple data frame manipulation. You see that the players occur in the acquired and relinquished columns. In this data, a player can't be acquired and relinquished at the same time, and the one that doesn't have an object will be represented as nan. We want to filter out any nans, and we know that a single entry won't have both required and relinquished set to nan, so we'll do this by setting the nans to be an empty string and combining the 2 columns into a single column. This allows us to create another column called name that includes the name of the player. Now let's do something different. Say I only want to look at the top 10 players that are in this data set, people who get injured the most. We can count the occurrences of the names by using the value counts function that acts on a series, and then we'll sort their values and get the top 10 using the head function. And we see that the top 10 players who've either had injuries or been acquired or relinquished from injury leave the most are legends like Dwayne Wade, Kyrie Irving, and Derrick Rose, so this is really not surprising. We can also index our original data to select only the players that appear in this category, like so. So these examples show 2 different ways that we can manipulate data. We can first extract data from a dataset and manipulate that data independently, or we can actually manipulate the data frame directly. There are many manipulation and aggregation functions that are built into each object. I definitely suggest looking at the documentation to figure out what functions are useful for what you want to do, but honestly, Google is your best friend for finding pre-cooked recipes for Pandas manipulation. Many of these functions are also built into the entire Pandas module, so definitely look at that documentation if you're curious.
No, I don't need the pain. Not in it for the game.
Now let's get into some data visualization, which is actually really simple with Pandas. Pandas has some built-in Matplotlib plotting capabilities using the dataframe.plot and series.plot set of functions. You can create stacked area plots, bar and box plots, density and histogram plots, as well as line and pie plots, just like we can in Matplotlib. There are a few more for the data frame, but that's because the series can only represent one dimension. So now let's use a plot function just to do some simple visualization of the injury data, and we're just going to visualize the number of injuries that these top 10 players have using bar plots, pie plots, line plots, and density plots. Pretty straightforward, so I'm not going to bore you with this, but definitely check out my last video on Matplotlib and Plotly if you're curious about plotting. There's also a built-in Pandas plotting submodule that provides some useful functions, but it's really not necessary for simple things. That's it for this video. In the next video, we're going to be talking about virtual environments for data science and machine learning, which can save you from what many people like to call dependency hell. I've been there a couple times, and trust me, you don't want to go. If you're interested in that video or any of the other data science and machine learning videos that'll be in this series, like this video and subscribe to my channel, and also hit that notification bell so you're notified whenever I'm posting a new video, which I think is going to be on Mondays and Thursdays at 12 p.m. Eastern time, if I'm on time. And if you want the code for this video, it'll be at this link, which is also in the description. That's it for this video, and I'll see you on the next one. Later.
I don't need the fame, and I don't like the games, and I don't like the way you want me to be wife